morning, children. Now we were discussing about metals and non-metals. We have already known that the elements are classified into three. What are they? Metals. Then the second, non-metals. In between these two, there is a few number. They are known as metalloids. That means metalloids shows both the properties of metals and non-metals. For example, boron, silicon, germanium, etc. are metalloids. We have already studied the physical properties of metals as well as the properties of non-metals. We have also seen some of the chemical properties such as reaction with oxygen. We found that metal when exposed to air, almost all the metals combine with oxygen to form its oxide. For example, iron when exposed to air combines with the oxygen in presence of moisture to form rust. Similarly, copper when exposed to air it forms verdigris. It's also known as, the chemical name is basic copper carbonate, copper hydroxide, copper carbonate, CuOH twice, CuCO3. Similarly, we have seen the reaction with the acids. Almost all the metals react with the acids, produce hydrogen. The metals zinc react with sulfuric acid to form zinc sulfate and hydrogen. Magnesium reacts with hydrochloric acid to form magnesium chloride and hydrogen. When metals react with the acids, it produces hydrogen. At the same time, copper does not react with the hydrochloric acid. On heating, copper reacts with the sulfuric acids. Similarly, the non-metals also does not react with the acids. Only the non-metal sulfur, in certain conditions, react with the nitric acid. Almost all the non-metals does not react with the acids. Metallic oxides, that is magnesium oxide, iron oxide, copper oxide, are basic in nature. At the same time, non-metallic oxides are acidic in nature. For example, sulfur. Sulfur burns in air to form sulfur dioxide. This sulfur dioxide, when dissolved in water, it produces H2SO3. This is known as sulfurous acid. H2SO3 is known as sulfurous acid, not sulfuric. It is known as sulfurous acid. Sulfur dioxide, when dissolved in water, sulfurous acid is formed. At the same time, sulfur trioxide, SO3, dissolves in water, sulfuric acid is formed. Or the main points you have to remember is metallic oxides are acidic, metallic oxides are basic in nature. Metallic oxides are basic in nature. For example, magnesium oxide. We have seen that magnesium oxide is basic. Copper oxide is basic. At the same time, non-metallic oxides, sulfur dioxide is acidic in nature. Because sulfur dioxide when dissolves in water, sulfurous acid is formed. Similarly, carbon dioxide, CO2, it when dissolves in water, carbonic acid is formed. H2CO3. Do you know what is carbonic acid? It's a familiar substance to you. Carbonic acid is soda water. The soda water you drink for when you are hungry, it is actually chemically it is carbonic acid. Carbon dioxide is dissolved in water at a high pressure. When you open the bottle, pressure decreases and there is a sound for escaping the carbon dioxide gas. Then we have to come to the another point. The reaction of non-metals with water. We have seen that reaction with water. Sodium and potassium, they are highly reactive non-metals. Highly reactive metals. Sodium and potassium are highly reactive metals. They react vigorously with cold water to produce sodium hydroxide and hydrogen. Similarly, potassium is also highly reactive. It reacts with water, producing potassium hydroxide and hydrogen. Here you have to remember two things. While we are studying the properties of metals, I told you that generally all metals are solid and generally all metals are hardened, but at the same time there are some exceptions. In the case of sodium and potassium, they are soft metals. We can cut it with a knife. Then the second point it is highly reactive. When water is added, it reacts with water to form sodium hydroxide and hydrogen. Similarly, potassium. So, sodium and potassium, they react with water as well as the moisture present in the air. They not need the pure water. If moisture is present, it also reacts with moisture and burns. So, sodium and potassium are kept in kerosene. So, you have to name the two metals which are kept in kerosene. Why? The two metals which are kept in kerosene are sodium and potassium. Why? To prevent the contact between water or moisture. If water or moisture is in contact with the metal, sodium, potassium, it burns. So, you have to remember the two metals which react with the cold, even cold water is sodium and potassium. The two metals which are kept in kerosene is sodium and potassium. Why sodium and potassium are kept in kerosene? Because it is highly reactive. It reacts with the water and moisture present in the air. So, sodium and potassium are kept in kerosene. Similarly, almost all the non-metals are not react with the water or air. But there is one non-metal which is highly reactive. That is phosphorus. Its symbol is P. Phosphorus. It is highly reactive. It's at a room temperature it burns. Around 30 degrees centigrade it burns. So, to lower the temperature, phosphorus is kept under water. The element phosphorus, it's a highly reactive non-metal. A highly reactive non-metal. It's a highly reactive non-metal. Where it is more reactive. Where it is kept? It is kept in water. Why? To lower the temperature. At a room temperature, it will be. Do you know what is the room temperature? We all know that in summer season, the temperature rises up to 37, 38 degrees centigrade. At room temperature means around 30 degrees centigrade. So, if it is open in kept in air, it will bend. So it will lower the temperature. Phosphorus is kept in water. There you don't confuse between these two. What are these two? Sodium and potassium are metals. They react with water, so they are kept in kerosene. At the same time, phosphorus is the only more highly reactive. It's not the only. It is highly reactive non-metal. There is many other non-metals where it's more reactive. For example, chlorine. Chlorine is the more reactive. The topest reactive non-metal. Here, phosphorus is also a more reactive metal. Here, the peculiarity is phosphorus burns at a room temperature. So, where is phosphorus kept? It is kept under water. Why? To lower the temperature. Then came the displacement reaction. Here we take 4 solutions. Here, copper sulfate. Here also, copper sulfate. Here, zinc sulfate. Here, ferrous sulfate, FeSO4. 4 salts are taken in 4 conical flasks, namely A, B, C, D. Then, the first copper sulfate, there we have to dip an iron ore. Here we have to dip a zinc ore. Here we have to dip on again a copper ore. Here we have to dip a tin ore. What is a sprint? 4 solutions are taken. 4 salt solutions are taken for conical flask. We can consider one by one. In the A, conical flask A, the salt solution is taken is copper sulfate. A metal piece of iron is dipped in the solution. Then after some time, what we can observe, the outer surface of the copper is dying. The outer surface of the iron is covered with the copper. Here also the zinc, the part of the zinc rod where it is dipped in the copper sulfate solution, it is covered with the copper. But in the case of zinc sulfate, where dip the copper, there is no reaction. There is no reaction. Here also ferrous sulfate, when they dip in tin rod, there is also no reaction takes place. What we can, this is the first thing, what we do in the experiment. Second thing, what we observe. The third thing, what conclusion we reach. The first test conical flask copper sulfate is taken in which iron rod is dipped. The observer is iron rod is covered with the copper. That means iron displaces this copper from copper sulfate. It is covered on the outer surface of the iron. The second case also zinc displaces copper from the copper sulfate. It is on the outer surface. The third case, there is no reaction. The copper cannot displace zinc, so there is no layer is formed. There is no reaction. The copper cannot displace zinc from zinc sulfate. What is the reason? We can find out the reason that A highly reactive metal displaces a less reactive metal from its salt solution. The point we have to remember is a more reactive metal displaces a less reactive metal from the salt solution. Here, iron is more reactive than copper. So, iron can displace copper from the copper solution. Similarly, zinc is more reactive than copper. So, zinc can displace copper from copper solution. At the same time, here we see that zinc is more reactive than copper. Here we can see the reverse. Which metals are here? Copper and zinc. Which is more reactive? Zinc. A less reactive metal cannot displace a more reactive metal from zinc. Here also, tin is a less reactive metal than iron. So it cannot displace iron from the iron percentage. So, what is our conclusion? First, we have to learn that no two elements are identical in their reactivity. Note it. Now only we have discovered 118 elements. The total elements we have discovered is 180. Out of 118 elements, the elements are classified into 18 groups of similar properties. Though there are similarity in the properties of some metals as well as some non-metals, no two elements. The case of human being, we have already known that there are more and more human beings there. But no two human beings are identical in every shape or color. Similarly, no two elements are identical in their activities. There is slight difference between any two elements. Here in the case of metals, if we take the case of metal, nearly more than around 90 elements are metals. The remaining are either non-metals or metalloids. These 90 metals, out of these 90 elements, no two metals have same reactivity. There is slight difference between these two reactivity. So here when you comparing the reactivity, iron is more reactive than copper. So iron can displace copper from copper sulfate. How we can study? In the higher classes, you have to learn the reactivity series. This for answering the questions, we have to study the part of the reactivity series. Then we can correct the answer. In the reactivity series, it was given to your notes. For example, potassium, sodium, calcium, magnesium, aluminium, zinc, iron, tin, lead, copper. The reactivity decreases. This is the reactivity series. Out of this 10 metals, the most reactive metal is potassium. Potassium is highly reactive. The least reactive metal in this series is copper. So we can observe this reactivity series when we take iron and copper. Which is more reactive? Iron and copper. The top metals come more reactive. When we come down, the reactivity also decreases. The bottom metal is the least reactive. When we comparing iron and copper, we learn that iron is more reactive than copper. So iron can displace copper from copper sulfate. When we compare these two elements, zinc and copper, zinc is more reactive than copper. So zinc can displace copper from copper sulfate. When we comparing copper and zinc, we have seen that copper is less reactive. It cannot displace zinc from zinc sulfate. Similarly, tin is below iron. Tin is below iron. Iron is more reactive. Tin is less reactive. So tin cannot displace iron from copper sulfate. So we came to what are the points you must remember? It is no two metals are identical in their activities. No two metals, not plane of metals, no two elements are identical in their reactivities. One is greater reactivity, at the same time one is greater less reactivity. In the case of this displacement reaction, the point to remember is a more reactive metal displaces less reactive metal from its salt solution. Then came to another point, how we can know the reactivity? The reactivity of the metals can be known from the reactivity series. It can be detailed study can be you in the higher classes. Now you must study up to this, then you can answer any questions. Answer to the questions. Then you will remember this point. The more reactive metal displaces less reactive metal from its source solution. Then the uses of metals and non-metals. What are the uses? We all know that a number of uses in your home. For example, iron. Almost all the metals are used for machinery, and what is the use of main? Iron is used for machinery. In the production of machinery, iron is used. Then in our kitchen vessels, utensils are used prepared from which element? Aluminium. The food we buy parcel food from the nearby hotel. The food is covered in wrap, that is aluminium foil. Aluminium foil is commonly used for covering the food parcels. Then the aeroplanes, such machineries are always used for machinery parts, vessels, utensils, and a number of uses you can find your nearby towns, workshops, in your homes, cooking plates and cooking vessels, etc. There are certain qualities. Copper is mainly used for making electrical appliances because there are the electrical conductivity. Copper is, and same aluminum is mainly used for cooking vessels. Therefore, because they are the conductivity of the heat. A special property of the metal is used for the production of a special kind of instruments. Copper is used for making electrical appliances for two properties. One part are the one electrical conduct electricity way. Then what is second quality? It can be thrown into thin wires. That property is known as ductility. Aluminum is used for cooking vessels. What other property? Aluminum can be shaped into thin sheets. What is that property is known as malleability, and aluminum conducts heat very easily. Similarly, every items can be iron is used for making machinery parts because it is hard. That same aluminum is not so hard. So aluminum is not used for making machinery because aluminum is light but not hard. In making machinery parts, aluminum is used. At the same time, we all know that which element is used in the thermometer. While studying the property of the metal, I told you that the only metal which is same that the liquid state in the room temperature is mercury. Mercury is the only metal which is the liquid state at a room temperature. So it is the thermometer where you are when the hospital they are taking the temperature. If you have fever, you can see the tiny thread line, that is mercury. So that is why mercury is used because liquid state. It can change there are slight variations in the body temperature. So a property of that. Similarly, the uses of non-metals. First and foremost and very important non-metal which is used is, can you say, it is essential for life, oxygen. Oxygen present in the atmosphere. Without oxygen we can't live. While inhaling all the elements, nitrogen, oxygen, carbon dioxide, while exhaling, except oxygen, all are thrown out. Similarly, nitrogen. What are the main components of found in atmosphere? We all know that nitrogen 78%, oxygen 20%, argon, krypton, carbon dioxide, hydrogen and other gases, inert gases including 2%. The most abundant element in the atmosphere is nitrogen. Second, oxygen. Nitrogen is essential for the growth of plants and fertilizers, etc. Nitrogen is essential for the plant to develop fertilizer. It is in that way. There the main product is ammonium chloride. It is a fertilizer. The main constant is nitrogen. Similarly, antiseptic erosion is potassium permanganate. That is also used as chlorine. It's used in, we have seen that the purification of water. Chlorine is in the pump houses in municipal towns. Water is purified by adding bleaching powder. Bleaching powder contains mainly chlorine. Chlorine is passed through rice, lake and lake, then bleaching powder is put. It is a disinfectant. So, chlorine, disinfectant, nitrogen, fertilizer, oxygen, essential for living things. These are the uses of metals and non-metals. So, you have get a general idea about metals and non-metals. So, in this classification, metals, non-metals and metalloids. So, in your textbook, you go through the internet and first you take a printout of periodic classification of elements, periodic table. In the periodic table, you must, whenever you are studying chemistry or science, study about elements is must. If you want to study about elements, you must thoroughly know the positions of the elements in the periodic table. So, today itself, you take a printout of periodic table and place in your table, study table, and then unknowingly know the elements, their symbols, their positions in the periodic table, metals, non-metals, metalloids, then take into knowledge about the general chemistry. So the coming examination, the coming assignment, there are questions from these two chapters. What are they? The fibers and metals. Then you also take a note of metals and non-metals. First you have to study is you enter the kitchen and the metal used. Which metal is used for each purpose. You have to take the name of the metal. For example, aluminium vessels, aluminium. Then electric wire, copper. Then there are one more thing you forget. Do you know what to say? The ornaments you wear in your ear or your neck or your hand which is made of gold. Similarly, silver. These metals, gold and silver are used for making ornaments, or jewelry. Jewelry, they have great demands. Nowadays, you have great importance to gold. We are familiar with some uses, etc. So, these things, the metals in your home, the non-metals you can touch and you can't touch. Oxygen, nitrogen, chlorine. The chlorine you can smell. While you drink water from the public water supplies, you can feel the smell of chlorine. Then let us go to answers the question. The answers to the questions. When we came to the test work, take out the textbook and try to answer the questions. These answers must be written in your notebook. As soon as the school reopens, we will want to bring a notebook. First question: which of the following can be beaten into thin sheets? Which of the following can be beaten into thin sheets? We all know that only metals can be beaten into thin sheets. Then first of you will know that which are the metals? Zinc, phosphorus, sulfur, oxygen. Which are the metals? Zinc is only metal. Phosphorus, sulfur, oxygen are not metal. So answer is what? Zinc. Because it is a metal. This property is known as metals can change in thin sheets. This property is known as malleability or malleable. Second question: which of the following statement is correct? All metals are ductile. Which of the following statements is correct? All metals are ductile. All non-metals are ductile. Generally, metals are ductile. Some non-metals are ductile. What is the correct? Generally, metals are ductile. That means we have seen that there are some exceptions also. For example, sodium and potassium. We all know that this can be contained in air. It cannot be shaped into thrown into thin wires. The answer is generally metals are ductile. For example, all metals, we have studied that all metals are solids. That is a common property, but there are some exceptions. Generally, all metals are solids, but in the case of mercury, it is a liquid metal. Then the next question 3: phosphorus is a very reactive non-metal. B. Metals are good conductors of heat and electricity. Iron is more reactive than copper. Iron is more reactive than copper. Which is more reactive? Iron. Then the metals react with the acids to produce hydrogen gas. How can we test the gas? When a matchstick, lighted matchstick is brought to the hydrogen gas, it burns with a pop sound. Mark D if the statements are true and if it is false. Generally, non-metals react with the acids. Generally, non-metals react with the acids. False. Metals react with the acids. Sodium is a very reactive metal. True. Copper displaces zinc from zinc sulfate. False. Copper is less reactive. It cannot displace zinc. False. Coal can be thrown to ice. Coal means carbon, it's a form of carbon. It is non-metal. Non-metal cannot be thrown into ice. Then the question 5. Some properties are listed in the following table. Distinguish between metals and non-metals on the basis of these properties. Appearance. Metal, the properties you can see we are studying. So answer the questions. The properties of metals. Metals are lustrous and second hard and can thrown into sheets, can be thrown into wires. Good conductor. In the case of non-metals, non-lustrous, soft, can be beaten into sheets, can be thrown into wires. Poor conductor and poor conductor. The case of next question. Aluminium foils are used to wrap food items because aluminum is malleable. It can be beaten to thin sheets. Hence, it is used to wrap food. Give reasons for the following. Immersion rods. Immersion rods means for heating liquids are made of metallic substance. Immersion rods means immersion coils. Using heating coil, always heating coil, which are made of metal. Why? Metals are good conductors of heat and electricity. Give reasons for the following. Copper cannot displace zinc from the salt solution. Copper cannot displace zinc because copper is less reactive than copper. Only high reactive metal can displace less reactive metal from the salt. Next question. Can you store lemon pickle in an aluminium utensil? By what is lemon pickle? What is the acid present in lemon? Citric acid. So in lemon pickles there is citric acid. We studied that acids react with the metals. So in lemon pickles there is the presence of citric acid. It may react with the aluminum vessels. So it cannot be stored in aluminum utensils. Next question, match the following. You have to answer the questions. Gold, jewelry, iron, machinery, aluminum, wrapping, wood, carbon, fuel, copper, electric wire, mercury, thermometer. Next question, what happens when dilute sulfuric acid is poured on a copper plate? When dilute sulfuric acid is poured on a copper plate, bubbles of hydrogen gas forms on the plate. Metals when react with the react the acids produce hydrogen gas. This is because copper is a metal. Metal reacts with an acid to liberate hydrogen gas. What happens when ionides are placed in copper sulfate solution? Iron and copper, which is more reactive? Iron is more reactive. We learned that a reactive metal displaces. More reactive metal displaces less reactive metal from its solution. Then what's the answer? Copper is, ionides are placed in copper sulfate solution. Iron being more reactive than copper displaces copper from copper sulfate. At the Saloni took a piece of Viii charcoal and collected gas evolved in a test tube. How will you find the nature of gas? After burning the charcoal and collecting the gas evolved in a test tube, add a few drops of water in the test tube. Charcoal, we know that it is a form of carbon. It's one form of carbon. Carbon, when it burns, it from carbon dioxide is formed. When it is dissolved, I told you that carbon dioxide is dissolved in water, carbonic acid is formed. A few drops of solution of blue litmus paper and if blue litmus turns red, it is acid. If red litmus turns blue, it is basic. So you have to then associate Saloni took a piece of Viii charcoal and collected the gas evolved test tube. Write down the weird equations at reaction stage plane. C plus O2 gives CO2. Then CO2 plus H2 gives H2, CO3 carbonic acid. The questions are answers are given to you. Then first you must read the lesson. Second thing, you must read the notes. Then only you try to answer the questions. Write it down. Next question. One day Rita went to jewelry shop with her mother. Her mother gave her an old gold jewelry to the goldsmith to the polish. Next day when he brought the jewelry back, they found that there was a slight loss in the weight. Can you suggest the reason for the loss of weight? Aqua regia, that you have not this test. Aqua regia means a mixture of nitric acid and hydrochloric acid. The ratio 3:1. Hydrochloric acid 3, nitric acid 1. It is used to polish gold ornaments. When dipped in the liquid, the gold layer starts dissolving, which causes a reduction in the weight. The outer unpolished layer dissolves and the layer becomes shiny. That means we have that you do that when you went to the jewelry shop for purchasing gold. You know that the gold is a less reactive metal. It does not dissolve in any acid, does not react with any of the acids. But it dissolves in the acid, which is a mixture of hydrochloric acid and nitric acid. A mixture of hydrochloric acid and nitric acid in the ratio 3:1 is known as aqua regia. So, this gold does not dissolve in pure acid, but it dissolves in aqua regia. So, if we give the ornaments to the goldsmith, how he polish it? He put it in the acid. He put it in the aqua regia, then the polished layer will go out. Then there is a weight loss. There is, have to remember one more thing. If the gold does not dissolve in any of the pure acids. So, how if you know went to the bank for the money lenders, how they check the purity of the gold? They put the gold ornament, gold on the nitric acid. If any other substance is mixed with dissolved in the nitric acid, then the smooth surface will be going to change to rough surface. Thus, they test the purity of the gold. Do you know what I say? The gold ornaments, its outer surface is very smooth. If any impurities like other metals like copper or is included in it, if we put the ornament in a concentrated nitric acid, what happens? Gold does not dissolve. If there is no change in the surface of the gold, we can say that it is pure gold. If we put the ornament in the nitric acid, if the outer surface became rough, what our conclusion? There is some impurities like copper, other metals. It dissolves in nitric acid. So the smooth surface become rough. So the chapter is over. Yesterday we have already the notes were given to you. You have to study well, and after the honor celebration, you have to write the answers and give it to the office. You remember one thing, while writing the answers, you have to write the answer to the question, not in a detailed manner. You have to answer in a word. Answer in a word means you have to write the word only. Answer the sentence means you have to write sentence only. Not a detailed answer. Correct question number and the answer to the question. Not a detailed answer in a science subjects. Okay. Thank you all. Can meet again. The